Hello, everybody. It's 11:03, and we're going to start this latest webinar from Delta EE, Local Energy System Research Service. Today, we will be talking about opportunities for local energy system in commerce and industry sectors. But before we get into that, a brief introduction to Delta EE and our research service. Delta EE is a research and a consultancy company specialized in the energy transition. We offer bespoke consultancy projects as well as subscription to annual research packages on 12 different topics at the core of the new energy sector. The Local Energy System Research Service is one of them and looks at challenges and opportunities created by the growth of energy communities, microgrids, and local energy markets. Through an annual subscription, our client can access in-depth reports on business models, technologies, interaction between stakeholders and customer, case studies, and a database which showcase different types of local energy systems in Europe and around the globe. And opinion pieces such as our last viewpoint on energy communities and the just transition. I am Lodovica Di Diodato, manager of the research service, and I'm joined today by Jeremy Harrison, principal analyst. And he and I will be sharing in the presentation and are available to answer your questions. We planned around 30 minutes for the presentation, followed by 15 minutes for the Q&A. Please feel free to raise questions as we go along by adding them to the chat Q&A function. For today's webinar, we are going to look at what local energy systems are and how do they support the C&I sector already, and then move into how energy communities can serve C&I customers by giving examples from across Europe. But first, we are keen to know your opinion on how will commercial and industrial actors meet their emission targets. So we are going to start a poll. Please answer this question. Oh, perfect. The poll is already up there. So how will commercial and industrial actors meet their emission targets? So please select one. Through green certificates, through on-site generation and energy management measures, through carbon offsetting, through collective self-consumption and energy communities, or they won't. So maybe Jeremy, did we close the pool?
Okay, it's
yeah.
more coming in. There's quite a few votes there. So I'll close it in 3, 2, 1. So the answers to that, we have the majority, 44%, believe it can be answered through on-site generation and energy management. And then equal, around 20%, green certificates and collective self-consumption communities. And interestingly, only 5% of the audience believe that they won't. That's encouraging, I guess.
Okay. Thank you.
Okay, so thanks for that, Lotto. An interesting insight into the way that the audience is thinking. As Lotto says, today we're going to be talking about the challenges facing commerce and industry. They seek to achieve net zero carbon in their operations, and particularly about how local energy systems might. Now, I apologise to those of you who've seen this before, but some of our audience will be new to the subject. So very briefly, just an introduction to what we mean by local energy systems. As it says, it's small energy systems, small being relatively undefined, but usually containing renewable and at least low carbon energy resources matched with consumers, and in which the production and consumption of energy are largely balanced. The way that they can meet their goals along within collaborative communities means we're going to cover both bounded campus type systems, including microgrids, as well as unbounded virtual systems. In our previous webinar about energy communities, we talked about the way in which ordinary citizens could become more engaged with their own energy provision. The way in which the European policy, and more specifically the Energy Directive and the Electricity Markets Directive, are intended to encourage three things. One is about engaging consumers with renewable energy generally. It's about the provision of additional flexibility within the energy system as it becomes more decentralized. And thirdly, but probably most importantly, it's about releasing new forms of funding from individual consumers rather than from institutional finance or public sector financing. So, as I say, we're going to talk today about the ways in which CNI can be part of the energy transition. And that includes energy communities which are permitted under these directives and which Lotto will talk about in more detail. And we'll also consider how more conventional local energy systems and many other configurations have been used for some years to achieve that. And again, so we will be looking at the typology that we've shown before. And again, I apologize for those of you who've seen it before, but just to be quite clear what we're talking about, within this matrix of different kinds of local energy systems, we go on the left-hand side from just straightforward distributed generation embedded within the network without a matching demand, and on the far right-hand side to fully balanced microgrids where they have to balance clearly in real time, and in between the kind of virtual systems that we see, the ones in the second column, the ones in black, which Lotto will talk about, and then the ones in blue, which are the kind of campus type systems, and I'll speak a bit about those, and then one example of an actual microgrid. So if we look at the ways in which industry can resolve its targets, the first question we probably want to ask ourselves is, why should they bother? What are the reasons that CNI particularly need to consider the entire agenda? And there are the kind of the positive reasons about becoming a carbon neutral business, differentiating themselves in the market as the industry leaders, tackling climate change. It's very good for sort of CSR issues. But there's also some practical reasons. It seems that about half the UK workforce, for example, want now to work for organisations that have a positive impact on the world. And some recent research showed that up to 36% would claim they would actually work harder for an ethical company which benefits society rather than just for a higher salary. And clearly, as a climate leader, you demonstrate to your employees, investors, business community, and obviously your customers that you're planning for the future and voluntarily undertaking climate action. And the fourth, perhaps most important thing of all, is you can actually save money. You can future-proof your business against future energy price volatility, but you can also reduce your operating costs today with energy efficiency and, in many cases, through on-site generation. So apart from the sort of CSR and the efficiency benefits from pursuing the low-carbon agenda, it's also not a bad idea to try and avoid some of the negative issues, which include exposure to higher energy prices arising from new taxes and levies, which we've already seen in the past in many markets. And quite critically, in some cases, being disqualified from the supply chains of other B2B customers who require their supply chain to be decarbonised as well as themselves. And of course, there's also the possibility of direct penalties being imposed if you don't achieve certain targets in different countries. So lots of good reasons for doing it, but the question is, how do you go about it? And what we show here is that I would say largely two broad approaches, one of which is, I would say, outsourcing the problem to somebody else. And that includes the 3 points we mentioned here: carbon offsetting, green certificates, and power purchase agreements. Now, a lot of people are quite skeptical about the carbon offsetting approach. There's been recent adverts I've seen where for £6.99 a month, you can completely mitigate your impact, carbon impact on the planet. I, for one, am quite cynical about the idea that for such a little amount, you can actually save the planet. If that was the case, there wouldn't be such a challenge ahead of us. And most importantly, I believe that it's all very well outsourcing your certificates to somebody else, but in practice, somebody's actually got to do the work. And so when it comes to actually delivering on these things, then clearly the physical approaches are at some point going to have to be delivered as well. And those would include things like on-site generation. Clearly, if you can actually generate your own power on your own site, then you're not having to import carbon-intensive electricity from the grid. Obviously, things like efficiency, going for low emissions lighting, LED lighting, for example, improvements in HVAC systems, switching fuels, so moving from carbon fuels, fossil fuels, to electrification of heat and power, heat and mobility, for example. So there's a number of ways you can do that, and I'm going to talk a bit about that. And then, as I say, that I'm going to talk about the physical measures, and then Lotte will go on to cover the more innovative approaches, such as energy communities, which are capturing additional value and really a more, should say, inclusive approach. So the first example here, a couple of examples from Edinburgh just to show that it can be done anywhere. So this is on-site generation. It's simply solar PV on the roof of this community leisure centre. And what's interesting about it is not the actual amount of energy, it's about the business model in which the citizens form a cooperative to invest in the solar PV, which is then hosted by the city council and provides them on-site PV. So it overcomes the kind of the public sector finance issue, but it also means that citizens are engaging in the overall contribution of renewable energy to that building. And of course, that will save both costs and carbon emissions in this case. The next one, which is a far more traditional on-site generation. Again, as I said, I've used Edinburgh University in bits of patriotic here, our homeland, and you could actually see these same kind of schemes used in just about any university campus across Europe, and hospitals, those kind of large heat and power users, where you have a continuous or fairly continuous demand for both heat and power on site. And these have been implemented over decades and delivering significant savings in energy costs, which was historically their primary motivation, but clearly now also delivering carbon savings. So it's basically, as I said earlier, it's a win-win. You can actually hit your carbon targets and save money at the same time. And these are the more conventional approaches. Moving on slightly to the way in which it's not quite an on-site generation. So this is an example of an E.ON development, Cranbrook near Exeter. And this is a mixed development where there is it's a combined heat and power system where the heat is supplied to the residential buildings, the homes in the foreground there, as well as to the business park adjacent. And what's particularly interesting here is the synergies between the business park and the residential. So there's both the diversity of load, which means that you get a flatter profile of demand, which is more manageable, and that also opens opportunities for flexibility provision, but also in terms of the balance of the heat and the power, so that the heat can be provided to the entire development, but overcoming the challenges of the competitive market on electricity, the electricity can then be provided to the individual businesses, so that you actually benefit from the synergies between the heat and the power delivery. So that's something which I think shows great promise for the future. And then finally, just a brief comment on the London City Airport microgrid. The quote at the top: "Microgrids are the holy grail of new sustainable renewable energy networks." Was from the chairman of London City Airport. I'm not sure I say that level of enthusiasm, but I think it's a great approach to provide a microgrid where you are addressing the issues we talked about before of decarbonisation and energy savings, but also about providing the very important level of resilience to the sort of critical infrastructure of an airport. What's maybe a little bit disappointing is that most of that is from CHP, gas-fired CHP, and a relatively small contribution from solar PV, only about 6%. And I think so. Their heart's in the right place, certainly, to get the net zero by 2050. But what it does do is to illustrate the challenge of providing significant amounts of renewable energy in urban environments and in many environments. And the entire point of local energy systems is about exploitation of local resources. So What Loro's now going to talk a bit about is how you can develop the synergies between the very challenged urban environments where there maybe isn't the space to provide the level of PV for this particular installation, but where there are opportunities to capture the local resources and loads within the wider community. So balancing the kind of the residential and commercial and industrial aspects of it. So now over to you, Lotte.
Thank you, Jeremy. Thank you for the overview of these case studies, this example of on-site production. I'm now going to talk about energy communities and how they can help the C&I sector benefit from them while supporting the energy transition. And so in this case, how to also use not only the on-site production, but the production in the proximity and share it with other members of these communities, thanks to the new legislation. Yeah, you're already on the right slide. So as we, I think at this point we all know, there were two different directives that gave the right to define the terms of energy communities as being legal entities within the Clean Energy for All Europeans package. One is the Renewable Energy Directive, with the definition of renewable energy communities, and one is the Electricity Market Directive with the definition of citizen energy communities. Let's just have a look at what do they mean. So renewable energy communities allow participation of members that are in the proximity of a renewable energy project. Shareholders or members are natural persons, SMEs, or local authorities. Their primary purpose is to provide environmental, economic, or social benefits rather than financial profits, and they must include renewable generation. On the other hand, the citizen energy communities are open to natural persons, local authorities, small enterprises, but do not have to be in the immediate proximity. They may include renewable generation and/or energy services that can benefit members and shareholders. The member state of the European Union must transpose those directives into national laws. They have until December 2020 for the Electricity Market Directive and until June 2021 for the Renewable Energy Directive. It will be up to the states how they will translate those laws, and as we will see in the rest of the presentation, every member state has adopted a different approach. What I would like to stress here is that it should be clear that commercial and industrial activities can take part and benefit from discounts and adulation that the energy community form can give them, because this is something that sometimes it gets forgotten. So energy communities and citizen energy communities can be also an opportunities for commerce and industrial activities. Next slide, please. Another scheme that has been rolled out in different countries following the definition of the Renewable Energy Directive of a jointly acting renewable self-consumer is the collective self-consumption scheme, which is a local energy model which share an output of a pool generation assets amongst a group of consumers with the aim of optimizing self-consumption within the participants. The energy concerned can be electricity only or be multi-energy vectors with CHP, EV charging station, biogas, etc. It can be managed through a legal entity, such as an association or a company, but this is not mandatory in every member state. It has a legal perimeter that can be based on a distance, for example, 2 kilometers in France, that with exception can become 20 in rural areas, under a substation on a low voltage network, which is the case in Belgium, Italy, Spain, Slovenia, and often they set the condition for an energy community. In this case, multifamily building, which is, for example, the Mieterstrom in Germany, and similar schemes are also in Slovenia, Austria, and Italy. and at the neighbor level, which is the case of Greece. Also here, non-households, renewable self-consumer can benefit from those schemes as far as energy products are not their main commercial and professional activities. Next slide, please. So here I would now give you some examples of activities, commercial activities that have used the form of a renewable energy community or the collective self-consumption scheme to maximize the value from their, let's say, on-site energy production or production in the proximity. So here, I would like to start with two examples of collective self-consumption. One in France, one in Spain. The Spain is yet to come. This is the one in France. The rules that apply are, of course, different. In the first case, the one that you see here, we have a collective self-consumption scheme that works within a perimeter range of 2 kilometers using a bio-COP store rooftop PV installation and a veterinary clinic as a consumer, together with the bio shop, of course. In this case, the investment on the rooftop PV panels was made available by the regional energy COP, which is the ENERCOP Mid-Pyrenees. And the two activities joined as members to enable the collective self-consumption scheme, so to enable the rule in France. In fact, the ENERCOP acts as the personne morale organisatrice, which is the entity that manages the energy allocation and communicates with the DSOs according to the French law. Through this scheme, the commercial activities were able to achieve 20% of savings on the self-consumed electricity. Next slide, please. The second case is in Navarra, Spain, where a metal company have installed 120 kilowatt peak rooftop PV on one of the buildings and used the energy produced to power other 5 buildings in the same business park. This was not possible before, as the business park does not have a private wired grid and uses the public network wires. With the new regulation on collective self-consumption in Spain, all the buildings in a 500-meter radius under the same substation can share electricity, which is the case, which is valid in this case. The project developer claims that the payback period will be for the generation asset will be only 4 years, with a return of the 80% of the investment. We'll see. Next slide, please. Okay, now we continue our trip around Europe and we go to Belgium. Now I would like to talk to you about a renewable energy community for small and medium enterprises. So OSPI Green is the name of the community, is a renewable energy community that follows the European definition, where consumers and producers are under 2 different mid-voltage substations. This is in this case. It comprises 3 hospitals, 3 SMEs that share the energy made available by existing local renewable energy assets. And this was made possible by the new regulation on energy communities. In fact, the renewable energy assets were not belonging to the enterprises, but the members have acquired the total production of 2 renewable energy facilities owned by the local development agency and EDF Luminous. And with the purchase of the full production, OSPI Green also acquired the green certificates. The Belgian regulation also allows discounts on system charges that are shared among members. So basically, the members will be able to benefit from the sales of green certificates and discounts on network charges. For future reference, the energy community is planning on adding flexible loads, adding a battery, sell flexibility services to the local DSOs, and include energy management system and a VPP. Next slide, please. Now, last but not least, here an example of a big industrial facility in Slovenia that was involved in an energy community. Creators is an Horizon 2020 EU-funded project, which do not fall under the legal framework of a renewable energy community. However, it is a local energy system, and it is a collaboration between local consumers, public entities, the local DSO, and a large industrial site, which is one of the main energy consumers of Slovenia. According to the project, the Big Foundry plans to feed the waste heat in the heating network of the nearby towns of Koroška, Bela, and Genesice, with 15,000 inhabitants. A reduction of 50 to 70% natural gas consumption is expected with the implementation of a waste heat recovery solution for the two cities. This pilot case aimed to integrate and coordinate the traditionally decoupled energy sector, so electricity, heat, and gas at various levels, so supply, demand, storage, by leveraging on the available thermal and electrical storage units and maximize the profit of each stakeholder. This case is a synergy between residential users in an urban environment that can benefit from a close-by big industrial site to create a more efficient local energy system and save on fuel consumption. So this was it for now. We are now ready to take your questions about what we are just showing. Can you please write the question in the chat function?
Whilst we're waiting for that to load up, Lotto, just a question of clarification. You talked about the two directives, the Renewable Energy Directive and the Electricity Markets Directive, and the fact that those have to be transposed into national member state legislation with the date, I think you said, of June this year. How are they doing so far?
So we have different developments in different states. It is not surprising, and I tell you why. So, for example, we saw that Spain or Italy are pretty advanced in the transposition of the directives. They already have a legal definition of energy communities, definition of the perimeter for collective self-consumptions, while, for example, Germany doesn't. This can be explained by the fact that, for example, in Germany, there is already a long tradition and already association called community energies exist, and they exist from long time, and we have observed like a raise in community energies with the rollout of the feed-in tariff. So the existence of already those entities that in big part do already respect the definition of a renewable energy community probably will make us think that either Germany won't define other entities, or they will just, push it, I don't know, until next year to define them. On the other hand, I also have already a collective self-consumption scheme, which is the Mieterstrom. And so in a way, there are countries that already had similar type of organization as they are described in the directives. So that's what we have seen so far.
So are you saying that some countries in Europe were doing this in anticipation of the legislation, and that maybe the legislation or the directives were really aimed more at countries which hadn't previously taken much of an initiative? Would that be a fair...
Yeah, I think so. Yeah, I think so. It was, I mean, for certain countries, they needed a push, while others were already more advanced in those type of organization. Okay, a question for you, Jeremy. Maybe it's a bit provocative. Why do we need to use local energy systems? Isn't it easier to use green certificates or offsettings?
Yeah, well, I think I touched on my personal preference for what I think that offsetting is a bit of a cop-out. it means that you can carry on and not really engage with anything. And whilst it has some benefits in terms of spreading the investment from your offset into, for example, developing countries, into schemes there, which might not otherwise, ultimately we have to sort our own stuff out. You know, we can't just subcontract our emissions to somewhere else. So there are challenges in some cases where London City Airport, for example, mentioned that, you know, that there maybe just isn't enough space to get enough generation on site. And of course, that's where you can still have the benefit of, you know, nearby generations you showed in the Gesenice Steelworks example. So I would certainly say that some way of capturing physical resources is something we have to do in the end anyway, and that going for the source route it's kind of an intermediate. It's not going to solve the problem. It's a way of maybe encouraging investment in renewables and in you know, low carbon generation and heat and so on. But you know, ultimately, you've got to do something yourself. You can't just pass the buck to somebody else and hope that they will sort it out. So I think that yes, it has a role to play. The offsetting and PPAs and so on has a role to play in some areas where it isn't possible to do things yourself, and there are many of those. Certainly in high density settings, it's very, very challenging to get enough local generation to meet the local demand. But certainly as a priority, we should be thinking about investing in physical assets and actually delivering savings ourselves. And of course, not to mention the obvious thing, which is trying to use less in the first place by having more efficient systems and more efficient products like, say, LED lighting and you know, variable speed drives on HVAC systems, things like that. So I hope that sort of answers that question.
Yeah, I think it is.
I can maybe throw one back at you, actually. We've talked a lot about, you know, the citizen engagement with the energy system and the fact that that has been quite challenging. I mean, it's been almost like a toy for rich investors. You know, we saw the investment in solar PV in many countries driven by people who could afford to invest in the capital cost, which was quite high initially, with the promise of rewards from feed-in tariffs and so on, and maybe leaving behind some other people. So clearly there's, you know, an incentive in now trying to bring the rest of the community along with us. But sorry, and that's seen as being quite a major contribution to the energy system. Do you see a similar growth expected in energy communities which involve C&I customers rather than just the residential side? Is it something that you're coming across more?
Well, this is a very good question, and this falls yeah, back in what we were saying before, that those are definitely tools for which the C&I sector can join the energy transition more easily. And as we were saying before, I mean, we have shown several cases where there is a synergies between households, and so residential customer and industrial customer, like the case in Genesice, where the industrial, so it was needed that there were like some residential customer in order to create a local energy system. So in order that the industrial activity, the foundry, was able to reuse the waste heat. So those synergies can really help each other. And considering that there are figures that expect a 40% of energy production being owned by citizens by 2050, I do see that this number could be grandly increased by the synergies between residential, commercial, and industrial. So and this is also what we're seeing. I mean, when we were showcasing these examples, there is definitely interest, is raising interest, and maybe we would also like to raise interest with this webinar and make the CNI actors understand that there is opportunities for them to join the energy transition, basically. So I hope I answered your question.
Yeah, well, I think that's what they were asking. So I think,
yeah.
I mean, talked about raising interest that clearly CNI customers, for them, energy is not their core business. They're there to produce things or to run hospitals or their companies, and energy is just one of their many issues. So clearly there is a temptation just to subcontract it to somebody else, outsource it, whatever. But I think it's interesting what you showed there with the obviously there's not that many steelworks around, but clearly that's one example where there's an obvious case to make use of that waste heat. We are seeing other examples, London Underground, for example, using the waste heat from the tunnels to provide space heating to the residential customers above it. So I think that there are certainly huge synergies between the different parts. I mean, in the same way that industrial complexes very often will try to optimize their processes to make use of waste heat from one part of the process to there's a demand for lower grade heat. And maybe this is just an extension of that into the wider community where residential space heating is a very low grade heat demand. And clearly there are many instances where industry has waste heat, for example. Without me carrying on, just to say to the audience, we will try and cover all the questions that you're placing, but those that we don't answer during the webinar, we will get back to you individually.
Yeah, a question for you, Jeremy. Yeah, I'm conscious of time, but I think we can manage to do this one. Okay, so Cramrock, the Cramrock example is owned by E.ON. How is that a community?
That's a good point. So that wasn't a community, energy community, in the sense of the European definition. What I was trying to illustrate there was the synergies between the business part, the commercial customers, and the residential side of things. So what I was showing there was that already today there are schemes which could be enhanced by the concept, the European concept of energy communities. And one of the things I referred to there was the fact that the operator E.ON is supplying the electricity from the cogeneration scheme to the commercial customers, because they can do that without running into trouble on the supply of power over public networks. Now, there are two ways that you could address that in order to capture the additional value from the residential customers. One is that, for example, if that were to be a private wire network, now unfortunately that's too big to fall under the exemption for competitive supply, but for smaller systems which were exempt and where you could have private wire networks, then effectively it becomes one big self-consumption scheme. But what that scheme now can do under European legislation, well, if we were still in the European Union, of course, what that could do is that the energy community could involve the whole of that development, including electricity supply to the end users, transacting energy over the network. So what this legislation is doing is enabling schemes like Cranbrook, which are great in terms of their energy efficiency, the cogeneration, the heat and power synergies between business and residential, how it takes it to the next step, which is to kind of optimize the electricity consumption within that community as well. And clearly, as we're looking to hitting the zero carbon targets for new build housing, for example, then we need to find a way of providing the energy services for those buildings as we construct them. And I think that's a great example of how it can be done. As you say, conscious of time, so probably just leave it there. As I say, any questions, we will get back to the people who ask those. Is that what?
Yeah, I think this is it for today. If you can change this, yeah, perfect. So thank you very much for your attention. Please reach out if you have any question. We will answer back the question that we didn't manage to answer today because of time. And yeah, we put a couple of links here so that you can access other contexts like these from the Delta EE webinars webpage. There are all the public webinars that Delta does on local energy system, but also on the other area of research that we cover. And if you're more interested in our research specifically, we also put in the slide the link to our webpage. So thank you very much. Thank you, Jeremy. And thank you to the participants.
Yeah, thanks everybody.